Welcome to space. Welcome to the Smash News Network. Congratulations on realizing our channel exists. Let's get into it. We saw another coronal mass ejection. We're going to relax our coronal mass ejection warning. Solar flare warning remains in place. Here's where the last coronal mass ejection came from, out of a C-class flare in a setting region in the northwestern limb there. We've also got three sunspot groups, this one up here, this one down here, and sunspot 2882. It's a star of the local star. And we've got lots of spectacular imagery to cover about things like heliophysics, astrophysics, etc. Let's take a look at the viewpoints from Lagrange point 5, the location of stereo A, and Lagrange point 1, the location of the Discover SOHO LASCO C2. And here's that coronal mass ejection we were just showing you there. It will miss Earth to the northwest. Stereo A on your left, the LASCO on the right. Again, for you new viewers out there, Stereo A is located here at Lagrange point 5, trailing the Earth orbitally speaking, and the Discover SOHO spacecraft is at, the SOHO rather, is at Lagrange point 1, right between the Earth and Sun. Here's 131 angstroms. It'll also show you that C-class flare coronal mass ejection event. And we do have more likelihood of geomagnetic storms on the way. So there is a coronal hole wind stream occurring currently. And we're also expecting another strike from another coronal mass ejection that was headed Earth's way, that is headed Earth's way. So here's a colorized magnetogram, again, sunspot 2882. These are also beta-class sunspots. The likelihood of solar flares is still quite high. Coronal mass ejection watch is sort of relaxed here, but the solar flare watch, solar flare warning actually remains in place. So here's the extreme UV wavelength of 1700 angstroms. Let's continue on and blast through a bunch of additional data here. Another interesting day. So the radio flux, which is the radio output from the upper chromosphere and lower corona, is what we'll cover next. Here's the one-year chart of that. The black line here is the radio flux. And it's come up to 85 here. So there was a bunch of plasma in between Earth and Sun. Some of that has subsided at this point. But again, there is still a forecast here for geomagnetic storms. And there's the updated data. You can see late today and early tomorrow, we're expecting up to a KP6 here in the hours before midnight universal time tonight. So you're talking about around 6, 7, 8 p.m. Eastern Daylight Time and into tomorrow. So that's a coronal mass ejection strike there. That's the Space Weather Enthusiast dashboard if you want to look that up yourself. Next, we'll take a look at global seismicity. Smash team would have been informed last night of the Hawaiian quake. There was a 6.1 magnitude quake south of Hawaii. We'll get to it. We're going to scroll up the list here to see what else has been shaken. Indonesia saw a deep quake at 4.5 magnitude. Estimated depth over 550 kilometers. If that occurred at the surface, that would have been a 6+ magnitude quake. Similar to this 4.4 at Fiji. That estimated depth over 569 kilometers. So there actually a 6.2 is what occurred there. And again, Smash team members would have been aware of this last night, shortly after it happened. Quite a significant earthquake there. South of the Big Island. Continuing on the list. A bunch of aftershocks there, no surprise there. A 6.2 magnitude quake is the largest of the past 24 hours. And let's look at volcanism. La Palma still erupting in an explosive fashion, still producing a 10,000-foot plume of volcanic ash, fertilizing the island and surrounding area. Parts of North Africa as well, providing lots of sulfur dioxide. Suwanosei Jima, flight level 080, over the Ryukyu Islands from Subanose-jima. Mount Ibu, 7,000-foot ash plume as it explodes over Halmahera, the Indonesian island. Semeru, located on another Indonesian island of East Java, exploding flight level 130. It's a 13,000-foot ash plume. Samisa Pochnoi, not provided a volcanic ash alert from Samisa Pochnoi. Don't assume it's not erupting if you're flying over the Aleutian Islands. Fuego exploding, flight level 160, 16,000-foot ash plume over Guatemala. Volcanic ash cloud has dispersed from Nevado del Ruiz, so a calming there of the eruptions in Colombia. Sangay exploding, 20,000-foot ash plume over Ecuador. I believe that is an uptick at Sangay. Revenador, the other Ecuadorian volcano that's been active recently, has dispersed its ash. And intermittent emissions from the Peruvian Sabancaya volcano are a reminder. Do not pull Volta Caldera, folks. Just don't do it. Do visit the links below the video, pick up some merch, help support the channel, increase the probability these videos will continue to exist and remain publicly visible and free for all to view. We need your assistance to keep the channel functioning, and the merch shop is one of the ways you can help us out. Pick up some gear. October is a great month to shop for gear. It makes great gifts as well. Remind your friends and foes to Mensa, make Earth not suck again, or perhaps Mansa, make America not suck again. Or perhaps wear the face of evil. Saint Fauci, the admitted fraudster who keeps committing fraud and keeps being used as a resource by news agencies who want to defame themselves. So welcome to the Neo Renaissance. Visit smAsho.com. You can find links to the smAsho merch shop right there, as well as to the forum. Thanks Nebo J for contributing to our clinical talk forum, smAsho.com/forum. One of the more recent subjects there is clinical talk migraines, transferred from YouTube comments. Go have a read, smAsho.com/forum. Also, if you're not aware of our mission, you can find the mission on the forum as well, smAsho.com/forum/mission. And let's briefly go over the mission here. It's to assist, study, and report on an ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space weather and Earth effects, to connect and consult with media organizations to multiply our reach, hence videos like this, to demonstrate cutting-edge proof of concept solutions to problems, like purchasing a bike because you're worried about prepping. Number 5, to publish scientific papers in a multidisciplinary manner, including but not limited to sciences like spectroscopy, chemistry, longevity, biology, magnetohydrodynamics, geology, to assist mankind by advancing the study of predictive phenomenon. Yes, predictive phenomenon. To optimize value and reduce risk and liability and save lives and resources and adapt, no matter what the adversity is. And last but not least, to not be ossified in our beliefs and to treat those who are with love, respect, and inclusion to the scientific discussion, as it takes a long time to catch up with some of the cutting-edge science, which is advancing at shocking speeds. So here are some of the spiky readings in the GOES magnetometer that we forecasted yesterday. It has to do with the arrival of coronal mass ejections and coronal hole high-speed streams of plasma. Anyway, that's a 3-day chart as measured by the GOES 16 and 17. Here's the magnetohydrodynamic data from the Gong 2. It's based on ground-based solar observatories, 51 of them on Earth, as well as out on stereo A here at Lagrange point 5 and stereo B here at Lagrange point 4. And as we forecasted yesterday, there is a South Pole current sheet now in charge of the earthly polaric situation of the plasma. So yes, South Pole current sheet there. You can see it in red. It's quite big. Just keep in mind the magnetic environment can change with basically no warning. The warning would probably come from our channel. So here's a line of sight ecliptic plane field plot. Shows the solar magnetogram as well, a great 3D representation of the heliospheric current sheet. Welcome to the South Pole current sheet, folks. Next, the line of sight coronal hole plot, and you can see some South Pole oriented coronal holes, which are trans-equatorial in nature, rotating into the Earth-facing zone here, so we can expect some high-speed winds from that. It's an uptick in coronal holes, as we forecasted, no surprise to our regular viewers. So here's the coronal hole view. It's 193 angstroms from the Solar Dynamics Observatory, and you can see the fairly well-defined coronal holes there south of sunspot 2882. Another well-defined one up here. And what is the polarity? Is it North Pole oriented? I would say it's probably North Pole oriented. And I do see a little bit of green up there. So that is indeed a North Pole oriented coronal hole. Next, the flare monitor. Solar flare warning remains in effect here mainly because of sunspot 2882. Looks like we had some umbra briefly appear over here on the east side. At the moment, all the sunspot groups are on the west side. West side. Next, looking at solar flares. We did see this mid-C-class flare here. The peak flux there was around 2250. Right around 2300 was the peak flux there. That C-class flare did cause a coronal mass ejection. We showed it earlier in the video. And we still see this ongoing proton event here. It's very minor, and it's associated with the M-class flare. This one back here did provide some relativistic particles, and they are still chilling up there in the geospace. Next, the real-time solar wind. And we could see a continued increase here in the solar wind speed. This was a fairly slow speed coronal hole wind stream that we've seen over the past day. So we may see the solar wind speed continue to climb here, although I doubt it because the temperature has leveled off. So anyway, the current conditions are 7.39 protons per cubic centimeter for the solar wind density, solar wind speed 374 kilometers per second. The rest fairly unremarkable. And here's the KP index, a measurement of global geomagnetism. We briefly saw geomagnetic unrest period late last night. Again, we're expecting some significant geomagnetic storms here. Expecting a KP6 later today, and some additional geomagnetic storming into tomorrow. Next, looking at magnetohydrodynamic pressure as modeled by the Space Weather Modeling Framework. This is 4 hours of data. If you want to know where it comes from, go to the Geospace Magnetosphere movie, click on details, and you'll find a link to the Space Weather Modeling Framework. You can read all about it. It's a lot of data points. Magnetometers, electron flux, proton flux, solar wind, etc. Fairly homogeneous pressure here over the past 4 hours. We'll look at ground magnetic perturbations also. Geospace delta B is changes to the Earth's B field. So we showed you the solar B field in the coronal hole line of sight plot. Here are Earth's B fields. I should say Earth's B field. It's really only one field, folks. The B field is the field that goes through a magnet, this magnet being Earth. And you can see perturbations here south of South America, also north of Asia. The South Magnetic Pole is someplace down here in the Southern Ocean, south of Australia during this polar excursion. Continuing on to look at a diagram of the solar system. Mars is very lonely at the moment. Earth is in the process. Earth is going to lose communication with Mars for a bit, as opposition is achieved. I'm not sure if that's happened yet or not. It's a fairly long process here. Anyway, that's where stuff is now. Let's advance it a week. Here's where things will be in a week. It looks like we're about 9 days out from another full moon, folks. And leave us a comment if you're a reverse vampire or reverse werewolf. More importantly, remember, folks, the 3 nights around the new moon involve reverse werewolves who are not hairy, who sleep at night and don't consume human flesh and are just generally good, nice people who don't worship Satan. Anyway, we've also got a star chart here. We've drawn in the ecliptic, which is the yellow line, the sun the path will take across the sky. And the blue line is the galactic plane. I use in-the-sky.org. This chart is the all-sky chart. If you want to make your own, put in your zip code. Today's cosmology segment will be very brief. We won't talk about any X-rays or anything like that. We're going to be talking about a flyby by Juno past Ganymede and past Jupiter. So some spectacular imagery here. Here's Ganymede. You can look at this yourself at apod.nasa.gov. We won't show the whole thing. Here is some Jupiterian Lightning, actually. You see some bright flashes there at the center of some of these low pressure zones here. Jupiter, it's a pretty turbulent atmosphere to say the least. Spectacular imagery there by the Juno. That's today's cosmology segment. Don't forget to check our other cosmology segments. We've got a massive playlist for cosmology segments. youtube.com/smashomash/playlists. And we've got some satellite charging hazards here over the Caribbean and northern South America. It could cause some communications disruptions. North of the equator there, some surface charging hazards for satellites, typically caused by electron flux. Here's the 1-year chart of the relativistic electrons. Those are measured at the F ionosphere layer, by the way, by geosynchronous satellites. You can find that data set, if you like, at solon.info. Here's a 3-day chart of the electron flux. The GOES 16 and 17 measurements there in blue and red, respectively. Fairly low levels here, as there is a coronal hole wind stream involved. There's the forecast model. I won't make any predictions about that in this video. That's the Noaa relativistic electron forecast model. And actually, I would tend to agree with these. I would agree with these forecasts, as there are expectations of a lot of plasma striking the Earth geospace. Next, the Van Allen belts, and we've got a great article here about the Van Allen belts if you want to read 21 fun facts about them. 21 fun facts about Earth's Van Allen belts here on SciTech Daily. I'll let the article scroll here briefly if you'd like to read the fun facts. I did highlight one of them here. The material in the radiation belts is made of charged particles, a material called plasma. Plasma surrounds the sun and pervades much of the universe. Now, an important thing to understand about plasma, folks, is that in space, practically everything is plasma, because material that is not within a magnetosphere is generally ionized by all of the radiation in space. Space is full of ionizing radiation, and in space, in a diffuse environment like the quote vacuum end quote of space, your plasma only needs to be about 20% ionized to be considered plasma. In other words, most dust and gas in space is indeed plasma. So calling everything in space plasma and saying, I'm a plasma cosmologist, therefore I understand astrophysics, is just nonsense. You can't just utter the words plasma cosmology and expect people to believe your nonsense. Next, looking at the total electron content forecast, we see fairly organized Van Allen belts, despite fairly low electron flux here. This will show you the likelihood of GPS errors. And the redder it gets, the more likely your GPS errors are to happen. It's a great reason to turn on location accuracy if you're using an Android device which uses Wi-Fi hotspots to help to calculate your position. Next, the diagram of the atmosphere here with things like temperature of the thermosphere, penetration of electromagnetic radiation, and the location of layers of the ionosphere. The F layer is located at about 300 kilometers of altitude, and here is an ionogram of that. And we see some massive low-frequency anomalies here showing up. They'll be more evident on the ionogram anomaly map. We'll show that next. We've also got some high-frequency anomalies, but mostly low-frequency anomalies here. Anyway, there's the latest image. Here's the anomalygram. This is the difference in megahertz, and you can see massive anomalies here around Oceania. Places like Papua New Guinea and Indonesia, seeing massive anomalies right here. In the low-frequency variety, also some low-frequency anomalies over the South Central Pacific. Also East Africa and the Central Indian Ocean seeing some big swings in the ionosphere as well. Some sudden transfers from high to low frequency anomalies there. Anyway, hopefully that helps. Here is the latest image. So 9 o'clock Universal Time, you can see there's a big low frequency anomaly there over the Central Indian Ocean. Do you only watch our space weather videos? Were you aware that meteorology segments premiere before them most days? Let's do bonus features. So here's the Lermonth, Australia, ground-based solar observatory. Quite a lot of filaments here. We may have to reevaluate our coronal mass ejection watch and warning. Again, we've exhausted that. We've shut down the coronal mass ejection warning, but the solar flare warning is still in effect. Great imagery there from Lermonth, Australia. And we're going to show you the latest intensitygram and magnetogram next. There's your intensitygram. Again, that's a beta-class sunspot. That's likely to produce significant flares. It's possible. This one is a beta-class sunspot, and that's a South Pole umbra there. This thing has straight-up reversed polarity here over the past couple of days. This one down here is a beta-class sunspot as well. Here's the latest colorized magnetogram. And we'll close out with some composite imagery here. This is 304 and 171 angstroms from the SDO, the Solar Dynamics Observatory. This is probably my favorite composite here, folks, as the 304 angstroms shows you filaments and 171 angstroms shows you magnetic fields. Great view of that solar flare and coronal mass ejection in the northwest as well. And here's just the southern hemisphere. Again, that is a sunspot there. It is beta class. And here's the north, where most of the activity is going on. Once again, thanks for tuning into the video. Congratulations on realizing our channel exists, and may that solar wind be at your back.